Welcome to the Deep Dive. Today, we're plunging into something that, well, it's pretty much everywhere, even if we don't see it. We're talking about substances so resilient, they basically laugh off attempts to break them down. Think nonstick pans, waterproof gear, even vital firefighting foam. These are PFAS, perachlorate, and polyfluoroalkyl substances. You've probably heard them called forever chemicals. And our mission today, to really unpack what they are, why they're a global worry for health and the environment, and crucially, how different countries are trying to get a handle on regulating them. We're drawing heavily from navigating global PFAS regulations and compliance, but also bringing in insights from the EPA, NIEHS, and health bodies in the EU and Canada to give you the full picture. It's a complex, moving target. Okay, let's unpack this then. Forever chemicals, PFAS. What exactly are we talking about here? What makes them stick around?
Right. It's a good question because the chemistry is key. PFAS are a large family of synthetic chemicals, fluorinated compounds specifically. They were engineered for some pretty amazing properties. They're incredibly resistant to heat, water, oil, you name it. And the secret, the reason they get called forever chemicals, it's down to these super strong carbon-fluorine bonds in their structure, these bonds. They're some of the strongest known in organic chemistry. So they just don't break down easily in the environment, or, well, at all, really, under normal conditions.
So that strength made them useful.
Incredibly useful, yeah. For decades, manufacturers loved them. I mean, who wouldn't want something that repels everything and withstands heat? It allowed for a lot of product innovation, so they ended up in tons of consumer goods, industrial applications, basically enhancing performance, often without us even knowing they were there.
And when you say widespread, we really mean it, don't we? The source material paints a picture of them being almost ubiquitous. It's not just the obvious stuff like cookware or stain-resistant clothes. It's critical things like firefighting foam, AFFF, specifically for fuel fires. But then also aerospace, cars, construction, electronics, even food packaging. It's kind of mind-boggling how pervasive they became.
Absolutely. It's a vast landscape. And within that huge family, we're talking over 9,000 different compounds identified to often come up first, especially in regulations. PFOA and PFOS. Think of PFOA, perfluorooctanoic acid, as maybe an invisible helper in making things like early Teflon coatings. It was used as an emulsifier, helping create those smooth finishes. PFOS, perfluorooctane sulfonate, was more about active repellency, making carpets or fabrics resist stains and water, protective sprays, some cleaners, that kind of thing.
So you might genuinely be surprised how many things you use daily have these substances in them or were made using them, kind of the unsung workhorse of modern manufacturing for a long time.
Exactly. And that leads us straight to the problem, the sort of unintended consequence. Because they were used so much and because they're so stable, they don't just go away. They build up in the soil, in water, in animals, in us. So thinking bigger picture, this persistence creates this long-term accumulating risk of contamination. It's a slow burn, but incredibly hard to reverse.
Okay, this is where it gets really interesting, or maybe concerning. We know they last forever, they build up. But why is that persistence such a big deal for our health and the environment? What are the actual dangers?
Well, the persistence is the foundation. But the danger comes because they're also quite mobile. Once they're out there, they can travel. So humans can get exposed in lots of ways. Drinking contaminated water is a big one. Eating food grown in contaminated soil or water. Using products with PFAS. Even inhaling contaminated air or dust. Their sheer presence everywhere and how they move through ecosystems makes it really hard to avoid exposure completely. And what's really tricky, as you mentioned earlier, is that there are over 9,000 different types of PFAS. That huge number makes it incredibly complex to research the specific health effects of each one. It's a massive challenge for scientists.
Okay, so with thousands of these compounds, is there like a key health impact people are most worried about? Or maybe what's the biggest headache for public health folks trying to deal with this?
That's a really important point. While there's a range of concerns, the impacts on children and development are definitely a major focus. Things like reduced fetal growth, that's particularly alarming because it's an early vulnerability with potentially lifelong effects. But the National Institute of Environmental Health Sciences, the NIEHS, links PFAS exposure to a whole list of potential issues. Things like altered metabolism, maybe higher cholesterol, issues with fertility, increased risk for obesity, and then more serious things like increased risk for certain cancers, kidney and testicular cancers pop up in studies, plus impacts on the immune system, potentially making people more vulnerable. Honestly, one of the biggest headaches for public health is probably trying to communicate this complex risk. People want simple answers, but the science for many of these compounds is still developing. It's tough.
Yeah, communicating that kind of evolving uncertain risk must be incredibly difficult. It really highlights the long shadow these chemicals cast, not just for individuals, but for health systems and the environment over decades. It's a massive puzzle. Which leads us right to the next obvious question. What are governments actually doing about this? Given how widespread it is, you'd hope for some kind of global response.
Well, the world is responding, increasingly so. Because of these risks, governments everywhere are starting to put regulations in place to limit exposure. And for businesses, understanding this patchwork of rules is becoming absolutely critical. It's not just an environmental issue anymore, it's a major compliance challenge.
So who's leading the charge, or what do these regulations look like in practice?
If you look at the EU, for example, they've actually been working on PFAS for over a decade. They've been quite proactive. In 2022, they brought in pretty detailed rules about PFAS sampling and testing. They mandate monitoring in food animal products, plant products, baby food, drinks, really trying to cover that consumer exposure route. And what's really striking is the limits they've set. They require testing that can detect PFAS down to extremely low levels, sometimes as low as 1 part per trillion for specific compounds.
1 part per trillion. That sounds incredibly tiny.
It is. It's like finding a single drop of ink in, 20 Olympic swimming pools. It shows the level of concern. They're focusing on about 28 specific PFAS compounds right now with very specific testing methods needed. The goal is clearly consumer and environmental protection, and it demands serious effort from manufacturers.
Wow. Achieving that kind of precision must be a huge challenge, especially for labs and maybe smaller companies.
Oh, absolutely. The hurdles are significant. You need incredibly expensive, highly sensitive equipment. We're talking millions sometimes. Plus, specialized training for staff, super clean lab environments to avoid contamination, strict quality control. For smaller businesses, the cost and expertise needed are often major barriers. They usually have to rely on specialized outside labs.
Okay, so the EU is setting a high bar. What about elsewhere? Canada, for instance.
Canada's also been on this for a while, showing a similar trend of tightening rules. They started restricting PFOS products way back in 2008. Then they brought in stricter rules in 2016 and updated their federal regulations again in 2022. But the twist in Canada for businesses is that some provinces, British Columbia, Ontario, for example, have their own additional requirements on top of the federal ones.
So it's layered. Federal rules plus potentially different provincial rules depending on where you are.
Exactly. It adds complexity. You can't just assume federal compliance is enough.
Right. And the U.S., what's the situation there?
In the U.S., the EPA, the Environmental Protection Agency, is definitely prioritizing PFAS, especially those big two, PFOA and PFOS. A key thing they're doing is the National PFAS Testing Strategy. This basically requires manufacturers to provide toxicity data on specific PFAS compounds. They're rolling it out in phases. Phase I covers 24 compounds. The FDA also gives guidance on PFAS monitoring in food, similar to the EU, focusing on things like baby food and water. But like Canada, the real complexity in the U.S. comes from the states. Many states have set or are setting their own regulations, particularly for drinking water, that can be much stricter than current or proposed federal levels.
Wow. So for a business in the U.S., it's not just one set of rules. It's potentially federal rules, plus this patchwork of different state rules across the country. That sounds like a real compliance maze.
It absolutely can be. Navigating federal and potentially 50 different sets of state requirements demands constant vigilance.
So given this complex, shifting landscape, what does this actually mean for a business making or selling products that might contain PFAS? How on earth do they keep up? And what are the biggest mistakes they make?
Yeah, this is where being proactive is just essential. You can't wait until there's a problem. The cost, financial, reputational, can be huge. A common pitfall is maybe thinking, oh, this doesn't apply to me, or federal compliance is good enough. That can be a dangerous assumption. So first step, companies really need to understand which regulations apply to them, federal, state, international, depending on their products, their processes, where they sell. And this isn't a one-off task. These rules are changing, so they need ongoing monitoring.
Okay, stay informed. What else?
Second, regular testing. Test the raw materials coming in. Test the finished products going out. Test the water used in their facilities. Finding contamination early is crucial. It can prevent much bigger headaches later, like recalls or huge cleanup costs.
Makes sense. Catch it before it gets out the door.
Exactly. Third, documentation. Keep meticulous records of all testing. Sampling methods, results, everything. If regulators come knocking or during audits, you need that proof of compliance. It's basic due diligence.
Right, the paper trail.
Fourth, train your people. Everyone involved, from sourcing materials to manufacturing to shipping, needs to understand the risks and the procedures. Consistent awareness across the board helps prevent mistakes.
Get everyone on the same page.
And fifth, consider partnering with expert labs. Given how tricky the testing can be, especially hitting those ultra-low limits we talked about, working with labs that specialize in PFAS ensures accuracy and that you're following the required methods. It's often a necessary investment.
So those 5 things: stay informed, test regularly, document everything, train your teams, and partner with experts. Seems like a solid framework, but it still sounds like a massive undertaking, potentially very expensive. Is that the biggest hurdle? Cost.
Cost is definitely a significant hurdle, no doubt, especially for smaller companies. That's often why using specialized external labs can actually be more cost-effective in the long run than trying to build that capability internally. But maybe the biggest mistake I see is companies underestimating the scope, thinking PFAS is only in one specific input, or that their existing quality checks cover it. They end up reacting to problems instead of preventing them, and reacting is always more costly.
Being proactive versus reactive.
Precisely. And just to give a practical example, labs like Meriu Nutrisciences, mentioned in our source, offer these kinds of specialized services. For the EU, they use advanced methods like LC-MSMS, that's a highly sensitive technique to test things like baby food or vegetables down to those 1 ppt levels. For North America, they use methods aligned with FDA or ETA requirements, covering the key compounds for food and water testing. These partnerships really help businesses navigate the technical side of compliance.
Okay, this has been quite the deep dive. We've gone from understanding these incredibly persistent forever chemicals and why they were so useful, to the serious health and environmental concerns, the complicated web of global regulations popping up, and finally, what businesses really need to do to manage this.
Yeah, the key takeaway really is that these PFAS regulations are moving fast in the EU, Canada, the US. They're getting stricter, more specific. These chemicals demand rigorous testing and careful management. Businesses that tackle this proactively, they're the ones who will minimize risks, stay compliant, and crucially, keep consumer trust. It's really about responsibility and smart strategy now.
So, thinking ahead, as these rules tighten and testing gets even more sensitive, pushing industries towards alternatives, what everyday things do you think might change the most, or maybe even disappear? What's the next big consumer shift we might see because of all this? Definitely something to think about. Thanks for joining us on this deep dive. Stay curious and stay informed.